Be greeted, guys. So today I'll show you how to write the conjugate acids and the conjugate base. So Ca stands for conjugate acid and Cb stands for conjugate bases or conjugate base. So there are rules for you to follow when you want to write the conjugate acid base pairs. So if you want to write a conjugate acid, you must know that you add one hydrogen atom and you add one ion or one electron. You'll see what I'm talking about. For you to write the conjugate acid, you have to add one hydrogen atom, then you add one electron. Then for you to write the conjugate base, you subtract one hydrogen proton and you subtract one electron. I don't know if you understand that. Now let's just write it, the conjugate acid of H2O. I am saying that for you to write the conjugate acid, you have to add one hydrogen atom. Since we have two, it means that we'll have H3. We added one hydrogen proton. Then we also have to do what? To add one electron. Now, since you have the net charge here, remember we did that when we were talking about the redox reaction or discussing about the redox reaction or the oxidation numbers. So if you haven't watched it, make sure that you go there and watch it. Okay, now since here we are having 0 like that, for example, let me say we had something like this, the net charge will be that negative. But now since we are having 0 here, it means that we'll add 0 plus 1. Or we will sum 0 and the 1. Why am I saying that? Because I just told you that whenever you want to write a conjugate acid, you have to add one hydrogen atom as well as one electron. So 0 plus 1, it will be 1, then we write plus. So that's the conjugate acid. For you to write the conjugate base, opposite is true. Since here we were adding one hydrogen atom plus what? The electron. Here it means that we're going to subtract one hydrogen proton or one hydrogen atom, and we subtract also the electron. So since we have two hydrogen atoms, it means that we'll have one hydrogen atoms. Then we have one O, right, or oxygen atom. Now, how many electrons are we having? We have 0. 0 minus 1, we have minus. So that is how we are writing what? Our conjugate acid base pairs. Let me just do the second example for us to understand what I was just writing there. For an example, let me say we have HSO4 minus. Then we write the conjugate acid and here the conjugate base. We know that when we write the conjugate acid, we have to add one hydrogen atom and we add one electron, right? So since we have one hydrogen proton there or one hydrogen atom, we have to add another one. We'll have 2SO4. Now, since we are having the net charges -1, we'll say minus 1 plus 1. We'll have 0, right? So we leave it like this. It is H2SO4. For us to write the conjugate base, we simply have to subtract one hydrogen atom and we subtract one charge. So we are already having one hydrogen atom there. So it means that we'll subtract it, we'll be left with SO4. Since we know that we subtract one hydrogen atom, then we subtract the charge. Since we are having minus 1, it will be 2 minus. So this becomes what? Our conjugate base. I don't know if you understand what I'm doing there. The third example, let me say we are having NH3 ammonia. That's a base, right? So it is very important here in acids and bases to know the examples of the bases and the acids. Let me say we're given something like this. I don't know if we're going to have what we are expecting. So conjugate acid, you do not forget that when you write the conjugate acid, you must do what? You must add one hydrogen proton or one hydrogen atom and add an electron. Then Cb opposite is true. Now, Ca, we have to add one hydrogen proton. Since we have 3, we have 4 now. Since we have 0, the net charge, 0 plus 1, we have 1. Then we say plus. That's our conjugate acid. Let me say we were also asked to calculate the conjugate base. We won't be asked, but let me just do this to show you what we are doing here so that you can understand all of this. Because this is already the base, it matches with what? The conjugate acid. But let me say we do the conjugate base of NH3 just to understand what you are supposed to do. So since we know that whenever we are supposed to write the conjugate base, we have to do what? We have to subtract one hydrogen proton and subtract one electron. Now since we have 2 hydrogen protons, we'll have, since we have 3, we'll have 2. Then 0 minus 1 will have minus, right? But we won't have this because actually here I just wanted to show you on how to write the conjugate base pair, the conjugate acid base pairs. Let me just take another one, the last one. I hope you are understanding this. Let me say we have OH. This is actually the hydroxide ions. Ca, let me say, okay, let me just do this so that we can understand the way of writing the Ca and the Cb or conjugate base pairs. For us to write Cb, you remember we add one hydrogen proton and one electron. So since we have one hydrogen there, we'll have OH2. We know this is H2O, so we write O on the right. Minus 1 plus 1, it will be minus 1 plus 1, right? It will be 0. Then we leave it like this. This becomes what? Our conjugate acid. Do you see that? So we only use this, we only use the conjugate acid and the conjugate base. For you to write conjugate acid, you subtract, you add one hydrogen atom, then you add one electron. Then for us to write the conjugate base, we do what? We add, we subtract one hydrogen proton and we subtract one electron. Even for this one, they won't ask you to write the conjugate base because actually this is the base, right? But I'm just showing you how to do this. So if we were asked, they won't ask this. I don't know if you understand what I'm saying. I'm just showing you how to find the Cb or the conjugate base of any other element or compound or whatever. So Cb is, we know that we subtract one hydrogen proton. So since we have one here, it means that we won't have any, right? It will be O. Then since we have minus there, we have to minus again another electron. We'll have minus 1 minus 1, it will be 2 minus. But this won't be there. I'm just showing you how to find their conjugate base. I hope you understand that. Now they can also ask you to find the conjugate acid base pairs in a reaction. Sometimes they can give you the reaction, then they ask you to write down the substances that represents the conjugate acids. So it is very important for you. Let me say you are given, so we see that this is actually the reaction, acid plus base, these are reactants. Then this arrow shows us that whatever that we are having on the right are the products. Now they can ask you to indicate the conjugate acid base pairs in reactions. For an example, we are given NH3. NH3, they add what? They add, for an example, let me say they add water to produce NH4 plus NH4 plus with hydroxide ions. Hydroxide ions. Then they ask you to indicate the conjugate acid base pairs in the following reactions. So the most important thing for you to know, you need to know that is NH3 a base or is NH3 an acid? That's what you have to know. And NH3 is what? It is a base. Now since it is a base, it means that H2O, it is an acid, it is an ampholyte. You remember what an ampholyte is, right? It's a substance that can react as either being what? A base or an acid, right? Now, for us to do what? For us to indicate our conjugate acid base pairs, you know that this is what? It is a base. Now since it is a base, each conjugate, it will be what? It will be an acid. So since it is an acid, but each conjugate, it will be what? It will be a base. I don't know if you understand that. But if you are not sure, you just do this. Since this is a base, it means that we'll find its conjugate acid, right? Since it is a base, we have to find its conjugate acid. Now, if it was an acid, we have to find its conjugate base. We know that for us to write a conjugate acid, we have of a base, we have to do what? We have to add one hydrogen atom, then we add an electron to be NH4 plus. Why are we saying 4 plus? Because there's a 0 there. 0 plus 1 will have 1. So plus depicts the 1. And we can see that we have the 4 plus. It means that this is the base and this becomes what? The acid. I don't know if you understand that. Now we have water. Water here acts as an ampholyte because it can react as a base or as an acid, depending. It depends on if water it is combined, or if water reacts with a base, it becomes an acid. If water reacts with an acid, it becomes the base. So it is known as an ampholyte. So this goes to that. Since this is what it is, the acid, we have to find its conjugate acid. So this is how we're going to do it, or this is how we are indicating them. Let me just write the second one. We have NH4 plus, we have H3PO, H3, what am I saying? Okay, H3PO4, H3PO4 plus, OH minus. We have H2PO, H2. Okay, sometimes they can give you something like this, then they want you to continue with what? With the products or your reactions using Lorry and Bronsted theory. So Lorry and Bronsted theory, they tell us about the conjugate acid-base pairs. So we have to know what is this. So this is what it is. The acid. Why? Because it is combined with the base. I don't know if you understand that. So since it is the acid, we have to find each conjugate what? Conjugate base. So each conjugate base, we know that when we write the conjugate base, we have to do what? We have to subtract one hydrogen proton or one hydrogen atom, as well as one electron. So since we have two hydrogen protons, hydrogen atoms, will have two hydrogen protons, PO4. Now 0 minus 1 will have minus 1, then we put minus. We know that here we are having H2PO4 minus. That's what the conjugate base, plus OH minus. We know that it is what? It is the base. It is the base. So we have to find it conjugate acid. So conjugate acid becomes, we know that we do what? We add one hydrogen proton, or we add one hydrogen atom and one electron. So since we have one hydrogen atom there, we'll have H2O, then minus 1 plus 1 will have 0. Then we leave it like that. We have H2O. So we wrote the conjugate acid base pairs, or we wrote the conjugates of the reactants here. So this is how we are supposed to write it. don't know if we are together here. Then it is also balanced. How many hydrogen atoms do we have? This side we have 3 plus 1 is 4. H2 it's 4. P we have 1, we have 1. We have 4 oxygen atoms plus 1 is 5. 4 oxygen atoms plus 1 is 5, and it is also balanced. So this is how we are supposed to find the conjugate acid-base pairs. Do not forget to subscribe, please. Do not forget to subscribe, like, share, and comment. Is a way of thanking us.